Naveen is a network reliability engineer at Roblox, traveled from the Bay Area to join us today.
Yes.
Your arms don't look that bad, so you must have let somebody else do the flying. I'm still trying to vamp a little so we start on time. Sorry. Again, this is Naveen's first time presenting at NANOG. Hopefully it won't be your last. It's a pleasure to have you speaking with us today. Please.
Thank you so much. Hello, everyone. I know this is the last presentation before the break, so you guys tired. So I'm going to try to say AI every 5 minutes so that I can get your attention. But all right, let's start with the presentation. So my name is Naveen. I work as a network reliability engineer in a very small automation team at Roblox. And today I'm going to talk about the network telemetry architecture that we have in our company. So I'm going to start from like how we used to collect before, and then why did we decide to explore a new system and the architecture of the new system, and then some of the key takeaways from this presentation. So let's start with the legacy architecture. So the diagram that you see on the right is the entire telemetry pipeline that we have right now. But for this presentation, we're going to focus only on collectors/passes that you see in the big black box. But I'm going to give an overview of the other components right now so that it makes sense. So let's start with the collectors. So collectors, they connect to the network devices, fetch all the metrics using show commands, and then we have something called passes where we define what data we want to extract from these metrics. So like if you're doing show interfaces, we don't want to send everything to the database. So you can define, hey, I want errors or I want bytes, and then you send that to time series database. But wait, like how does the collector know what devices to connect to? So if you see on top, we have something called a scheduler. So scheduler fetches all the network devices from Netbox and all the metadata as well, like platform and stuff. And it will send it to RabbitMQ, which is a message broker with a bunch of queues. And we send unique device lists in each of these queues. So on the collector side, so every collector has its own queue because so collectors are distributed across DCs and POPs. And there are hundreds of collectors. So every collector will have its own queue, and the scheduler ensures that they always get the unique list. So the collector doesn't care. They just take the device list and just starts connecting to the devices. So let's go back to the collectors, and that's what we're going to talk about in this presentation. It's written in Python. We collect from all these devices every 2 minutes, and we use REST API and netconf for it. And obviously, when you're dealing with devices, you need to have some kind of concurrency. So in this case, we were using threading for it. And we always keep a connection open with RabbitMQ so that we can keep getting that device list if it's getting updated. So now, when I was talking about this old architecture, everything sounded great. Then why did we decide to explore a new system? So there were three major reasons why we did that. The first one was we wanted a scalable system that can handle the growth of our network. Roblox network was growing really fast. We were having multiple DCs, and we know the old collector couldn't handle it because now imagine if one collector can handle like 20 to 30 devices. Imagine if you want to handle thousands of devices, you need so many collectors. It will just be unmaintainable. The second one is network team wanted granular collections. They wanted to identify the issues as fast as possible. So they want to reduce mean time to reduction. Well, for that, you need faster collections, which again, the old collectors will maybe be able to handle it, but eventually it will just struggle a lot. And the third one is we wanted a reliable system. We were seeing a lot of data gaps in the old one, 20-minute gaps, 30-minute gaps in time series database. And sometimes we were just missing devices. And it could be because of some deadlocks in threading, or we were doing passes in the same instance. So maybe it was CPU intensive. So that must be causing more issues. So now that we know what the issues are with the old collector, Now we want to start from scratch. What do we do? So what are the requirements for our scalable collector? Well, obviously, scalable architecture. Well, how do you do that? So what if we can disaggregate the collectors and the parsers, and they're two different things? Maybe that could help. And so what is the second requirement? Well, we need 30-second collections now. In the old one, we were doing 2 minutes. Now this is 4x. And we should be able to handle that easily. Third one, we need some kind of compiled language so that we can increase the efficiency. But also, it also means we need to have expertise in the team to do it. Like, we cannot write in assembly language, just read blogs 101 and just start writing that. The team should know to write in a language that is compiled. The other one is good concurrency. Obviously, again, dealing with devices, we need really good concurrency. And the last one is better instrumentation and easier to maintain. We need to expose a lot of metrics so that it's easier to debug. And obviously, we should be able to maintain it easily. So how can we do it? Maybe if it's statically typed, we can enforce type safety so that we can reduce the errors during runtime. Have a lot of rich libraries. Like, we don't want to write everything on our own. We want to focus on the core of our system. So we need libraries for that. And prioritize error handling. Have something that if there's an error, we take action on it as soon as possible. Like, we propagate the error so that it shows clarity in the code and it's easier to debug. And obviously, as I said, expose extensive metrics, have a lot of metrics, maybe have for the application health, but also maybe profiling metrics so that you can see the performance of how the system is doing. Now, so how can we solve this? We have two components that we can use. One is we can use Kafka. Kafka will, if we want to disaggregate, we need something in between. And Kafka is, in simple terms, it's just a message bus with very high throughput and low latency. You can just dump a lot of messages into it and it will be able to handle it. And it will also help us with 30-second collection because now we can scale it. For all the other points, now you need some kind of programming language. We have expertise in Go. We have services in Go already. So we decided to go with Go, and it has everything that we want. A better concurrency than Go for sure, than Python for sure. So how does this new architecture look? So if you look at it, it kind of looks the same. But now the collector is broken down into 3 different components. Now we have collectors, we have Kafka, and now we have consumers. Collectors, so I'm going to explain this in the next few slides as well. But just take a picture of this, keep this in mind when I'm going through the next few slides. A collector is going to do just one job: connect to the devices, get the metrics, send it to Kafka, don't care about it. And then on the other side, you have these consumers just waiting to see messages in Kafka. Once it sees it, it will start passing it and then send it to time series. So before I go through all the components, so how are we collecting in the new collector? Now, we introduced GNMI here. We started testing it, exploring it, working with the vendors. And wait, has anyone worked with GNMI here before? Oh, perfect. We have people here. So if you don't know GNMI, it's like it's an interface or a protocol that uses gRPC to connect to the device to fetch data. In our case, we're using something called a sample mode, where you're creating a connection to the device, and you're saying, hey, send me interface data every 30 seconds, and the device will push the metrics to you, and you don't have to poll it. But if you see, along with GNMI, we also have REST API and FComp. Like, why do we have that? Well, we realized that GNMI doesn't have everything that we need. We wanted a lot of operational data, and GNMI didn't have it. And but there's always an argument that you can use native GNMI parts. So native parts are the ones that is maintained by the vendors itself. So if GNMI OpenConfig doesn't support it, you will probably use the native GNMI path. Well, it covered all the data that we wanted, but they were not following the OpenConfig convention and standards. And we don't want to cater to each of these vendors. I mean, it's kind of defeating the purpose of GNMI. So we decided not to use native models at all. And we use REST API and netconf as a fallback mechanism if GNMI doesn't support it. Now, so in the collector, so let's go to the components now. Now picture that diagram that I showed you again. Now you have the first one is the collector. So the collector is the one where we have a config file where we define all the show commands, and then we run it on the network devices. And obviously we send it to Kafka. But how do we correlate the show command with the network device? So this is how the config looks. This is a subset of the configuration. We have a lot of other configuration that I haven't mentioned here. So this is just for the command. So the first one you see is called paths. Paths is, in this case, GNMI paths. We're saying we want interface data. Then the next one is type, which is subscribe. We are using GNMI subscribe sample mode. You can do GNMI get. You can do netconf. You can do REST API. Then the next one is tags, which says vendor here. So this is how we correlate the device with the command. Now, if device A is, let's say, vendor A, we will put that in tags as vendor A. So when you're subscribing, so when you get the device, now you can correlate, or this path has this vendor A, so you have to get this data for that device. And the next one is topic. This is Kafka topic. I'm going to explain what a topic is, but for now, just imagine this. When I get all the data from the device, I have to send it to Kafka somewhere. I don't know where. So we mentioned that here, gnomi.interface.counters, so it goes to that topic in Kafka. And the last one is interval, which I explained before. We're telling the device, send me the data every 30 seconds. Now, we go from the collector, we have all the data, we send it to Kafka. Now, in Kafka, we need to have a way to segregate the data, right? You have all these show commands, all the output format, like what do you do with it? Now, there's a way to segregate all those messages. Now you can, Kafka does it by using topics. So now you can have one topic, and you can just write all the, let's say, show interface information to that topic. So you know what each topic has. And now you have thousands of devices writing to this one topic. Like, how will it deal with it? Like, there will be some kind of instability there. Well, it solves it by having something called partitions. And that's how Kafka scales. It can use, let's say if you're doing 10 partitions. So you need to, in the collector, you need to have some kind of hashing algorithm, just like a load balancer, and it will just distribute those messages into those partitions within Kafka, within the Kafka topic. So now everything is in Kafka. We have all the messages. Now, what does the consumer do? So the consumer is subscribing to all these topics, whatever we have defined. And now we need to know, we know what the topic has. Let's say in this case, the interface GNMI stats we get from interface. Now that is part of GNMI.interface.counters. So we know if we want to pass any data, we know how it looks. So now for every topic, we will have one parser that can just pass through the data. Like let's say if we want bytes and errors, drops, we can do that. And then same thing, we just pass through it, and then we send that data to time series database. So how does the consumer configuration look? This is again a subset of the configuration we have in the consumer. So the first line you see is backends in Flux. If you're using Influx time series database, you mentioned that there is extendable. Like you can have other databases as well. It's really easy to add. And you're saying, from this topic, gnomi.interface.counters, if you're fetching from that topic, use parser called interface_counters, where we define what we want to pass. And then you have measurement. Like when you're writing to time series database, you need to give a metric name to it. So in our case, we will say interface.counters, and let's say the metric is bytes. So you see, the metric in time series would be interface.counters underscore bytes. And the last one is parser type. In this case, it's genome data. So we're gonna say if you want to parse this data, you have to use genome logic. This could be JSON. This could be XML. Consumers don't care how you're collecting. If you're using netconf or any other protocol, if it's XML, it's just gonna pass it. If it's JSON, it will just pass it. Doesn't matter how you're collecting it. All right, so I explained the pros and explained the architecture of the new one. Like, so what were the pros and cons of this? Well, the first one was again, I've mentioned this before. Now we have, because of the new architecture, we have faster collections, granular data. We are able to accurately identify issues in the network. And now we have a system that can handle hundreds of devices. I have tested with like 80, 90 devices, but even if I make it like 120, 130, it should still be fine. And so there will always be some kind of trade-offs. Whenever we're building any system, there's always a trade-off. And in our case, now we have more components in the architecture. Earlier, we had only collectors, but now you have collectors, Kafka, consumers, which also means now we have slower deployments. Just imagine now if you want to add a new command, you have to add it to the collector, create a topic in Kafka, and then add a parser in consumer, which is kind of time consuming. But the benefits outweigh the cons, so it makes sense to us to do this. And deployment can always be automated. So that was the architecture, that was my presentation. What were the key takeaways from this? The first one is you should always evaluate your systems to see if you can incorporate the growth of it. So if you feel your company is growing, you're going to have a lot of new devices, evaluate your system to see, can we change the existing system to handle it? Or like what we did, you can maybe just redo the whole thing and figure out how we can scale easily. Like now the system we have, we know we can, even if you have another DC, we know we can just handle it. It's going to be so easy. Like we can grow 8x and we should be fine. So, and it's all because we have removed everything. Earlier it was like monolithic. Now everything is in separate, its own components. And now you have Kafka and you can scale really easily because they don't care about each other. The second one is do not rely on GNMI for your data. Its adoption is still in its early days. So with a caveat, so if you're working with GNMI, always, and if you see that they don't have data for what you want, work with your vendors and add that to the GNMI spec. Work with OpenConfig as well for that. And because we need more people to use GNMI, it's a really good protocol. But if you're not using it, we'll always have issues with it. And if we add, as a community, if we keep adding the fields that we want, it's going to help everyone. And the last one is, I guess, the most obvious general software best practice, that if you're maintaining software, if you want to make it easy to maintain it, always have a lot of metrics, have a lot of tests to ensure that it's easier to debug. Like, I think in software engineering, people always avoid this because we just want to get it done. Like we just want the service to be in production working, and then we think about exposing metrics. But trust me, when you prioritize metrics and tests first, it makes your life so easy. You have no idea. And also, if you have a new person joining, it's easier for them to also understand what you're doing. All right, so that's my presentation. before I finish it, I just want to give a shout out to my team. The first one is Maresh Gaitonde. He's the one who initiated this project, and he's the one who guided me throughout the project until its completion. So I just want to thank him for that. And then Brandon Bennett, who's a principal software engineer, we realized that there were not a lot of netconf libraries in Go. And the one we found had a lot of issues. One example is there was a Go routine leak, and we can't just keep fixing stuff. So Brandon had a side project where he worked on a netconf library, and then he continued to work on it, and we productionized it. And we are actively using it in production right now, and we're connecting to thousands of devices using that library. So if you want to check it out, that's his open source library, and I have a QR code to make it easier. And yeah, that's it. I'm open for questions.
Okay. Thank you, Naveen. You are no longer a first-time Nanog presenter.
Yes, thank you.
Do we have any questions from the audience? Come on down.
So you had mentioned that you don't see.
Please introduce
Oh,
yourself.
sorry. I'm James Harham with Internet2, do network automation work. You'd mentioned that OpenConfig, you don't see a lot of the schema in OpenConfig to get the data you want. Do you actually see that changing, or do you see vendors implementing their own specific?
So I didn't mention that. So the thing that I have seen is, even if it's there in OpenConfig, vendors don't have that field, even though it's part of it.
I
So
gotcha.
I'll give you a very simple example, interface flaps. It's the most basic stuff, but vendors didn't have that. So then I had to work with them to add it. But also, if there's a field that is not there in OpenConfig at all, you can work with your vendors to just add that, because I think they have more, it's easier for them to push to have fields than us, I guess. So
Do you see them being responsive to that request to add those fields to OpenConfig?
depends on the vendor. I'm not going to mention anything, but depends on the vendor.
Thank you.
Thank you. To the other side, please.
Hi, Tony from DevBox. And a question that I have is with the parser. Did you have to implement a parser for the output to InfluxDB? Because I've used that, but I haven't seen the ability to create a parser, especially when you're using Kafka into InfluxDB.
Yeah, so this is a custom logic. I couldn't add the parser stuff in the presentation because of the time, but these parsers, they're just YAML files where you can just mention the metric you want and how you want to extract it. And then when you're writing to time series, it's very easy to make it in a time series like influx format. And so we just fetch everything we want, just make it in Flux format, and just send it to time series. So it's all custom logic we have.
Okay. It's customized logic. So it's not built into the Kafka API into InfluxDB.
No, so the consumers, they are in-house tool.
Okay.
The consumers fetch it from Kafka.
Okay.
And then we pass through everything in the consumer, make it in Flux, send it to
Okay, so the
time
parsing
series.
is on the consumer.
Yeah.
Okay, thanks.
Yep.
Thank you. To the other side, please.
All right. I am Ruben with Virtual Technologies and Solutions. I want to find out your solution. Is it open to the public for somebody to pick up and probably improve upon, or if you have any plans of doing such?
Yeah, we talked about this when I started working on this project, but we just got this in production, I think last year. So we want to first ensure everything is fine, and then maybe eventually we may try to open source it if it's useful for everyone.
All right, thank you.
Okay. Kate, do we have anything from the outside world? Okay. To the other side, please.
Zach with Kansas Fiber Network. Do you see any kind of benefits with your sort of custom rolled solution over something like an open source solution like Telegraph?
Yeah, so we do have Telegraph. So, but the way we do it is from Kafka when we're consuming it, we have all this custom logic because we've seen all these issues with the data where there's another thing that consumer does, which is if the data doesn't look the way it should, we have something called transforms where it will just convert it into the format it should be. For example, in GNMI, when you're fetching interface data, the speed is called Ethernet underscore 100G. That's not a metric you can put in time series. So you need to have a bunch of transforms that you can use to just change that to what you want. And then now, and we also need JSON parsers. We need netconf parser, GNMI parser. So that was the reason why we have custom logic for it. And in Kafka, if you have 10 partitions, you need to have 10 consumers. You can have 10 n plus 1, but you will have 10 consumers, so they can fetch, and it's very CPU intensive. So yeah, that's why we decided to have our own. Actually, we are planning to remove Telegraph eventually, but all these consumers, they actually send it to Telegraph to time series database. I didn't mention that because it wasn't required, but yeah.
Cool. Thank you.
Okay. Is there anybody else with a question for Naveen? Going once? Going twice? Sold. Thank you, sir.
Thank you so much.